All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue learning about Rust. I Shortly before starting today's stream, I realized that yesterday I had said that we're gonna be pretty much done with this, and we're gonna be continuing working on something else. I can't remember what it was. It was either, oh yeah, there was probably the content pipeline and or well, in terms of what we could have been doing other than this is the content pipeline and Git branching. We still haven't finished that. There's still more like advanced stuff in that to get into. Honestly, there's even the basic stuff to get into. I don't think we've done that practically a whole lot. I think we created a branch, but I don't think we went into merging branches. Well, um, I continued with the Rust research off stream. There was random topics that I was curious about, and so I continued having my conversations with Gemini. And I guess we're just going to continue with that. Yeah. So I'm going to try my best not to get sucked into that whole thing about temporaries and temporary lifetime extensions. I'm just going to stop at the point where I'm at and just be like, yeah, okay, this is the this is what I know so far about this topic. I don't think I need to dive too deep into it because if I keep trying to do that, then it's just going to take time away from the other stuff that I really, holy shit, there's other stuff that I really need to be getting back to, and I've just branched out so much. Well, okay, so um, for now, currently, what I'm looking into is the Dyn keyword in Rust, and I feel like now I am in a better position to understand Dyn than I was previously because now I actually understand generics and trait bounds and stuff like that. So I feel like now I'm in a better position to understand exactly how I would be using Dyn. In the past, I'd understood that Dyn is used in situations where you don't know what the concrete type is going to be, but that's about it. That's like, I understood that on a surface level. I didn't truly understand what's happening under the hood, what's the reason. If I wanted to make a function that took, or in what situation I would be using the Dyn keyword. In what situation would I be creating a type that takes a dynamic, um, but well, I'm not sure how to say that. Um, in what situations I would be creating a, um, let's say a function maybe that, actually, oh shit, hit my eye. Yeah, okay. Actually, I need to see if that's a thing in functions as well, because so far the examples that I've seen and even practically the situations where I've used Dyn has usually been involving angle brackets, angle braces, and that's for types like vec and box, and there were a couple of other higher level thing. Give me a second. There were a couple of other higher level things. Even types from other libraries. I can't remember examples of ones, but yeah, there have been situations where I had to use the Dyn keyword. Okay, so I'm gonna read the explanation that Gemini gave about this. Oh, give me a second. Okay, so Gemini explained this in terms of static dispatch and dynamic dispatch. These are the two topics that, or well, dynamic dispatch is what Dyn actually accomplishes. And to kind of, I guess, to juxtapose that, um, Gemini is also explaining static dispatch because it's part of the same like subject. So let's read out what let's read out what Gemini said. Um, okay, so to really understand Dyn, it helps to contrast dynamic dispatch. Actually, let me read out the dynamic dispatch part as well. Okay, so your intuition is actually spot on. Dyn is exactly what you use when you don't know the concrete type at compile time. In Rust terms, we call this dynamic dispatch. To really get Dyn, as in to really understand Dyn, um, it helps to contrast it with how Rust usually handles traits, which is through generics, which is static dispatch. So with static dispatch, when you use generics or impl trait, as in when you specify like trait bounds, for example, or just use generics in general, Rust does something called monomorphization. And I'm actually glad that this was brought up because I'd actually forgotten the meaning of monomorphization until I read this again. It's one of those things where like I kind of remember that okay, when we are using generics, um the compiler is gonna do monomorphization to sorry, just zoned out for a second. Um the compiler is gonna use monomorphization to create concrete types, concrete versions of let's say the function. So if it's a function that takes in a generic type and you have called this function in three different places with three different concrete types, what the compiler will do is it'll generate that exact function but for each of those concrete types. So it'll generate three of those functions for you. The advantage, you don't have to write that code yourself. It's all being done for you. Okay. It looks at every concrete type you pass into the function and duplicates the code for each type at compile time. So that's what I was explaining just now. So the pros of this is that it's fast as lightning. There's zero runtime overhead because the compiler knows exactly what function to call. Cons, binary size can grow, also called code bloating, and you cannot store different types in the same collection. Okay, so the different types in the same collection, that's actually a good example of when Dyn would be used because that's an example that Gemini gave, and it's actually going to be like now we're going to read the dynamic dispatch part, and it explains over here how Dyn would be used even in something like Vec, for example. Okay, dynamic dispatch. Now, imagine you are building a game and you have a bunch of different UI elements, buttons, sliders, text boxes, etc. They all implement a draw trait, so they have a common trait implementation, a common trait bound. Well, I don't know if we would call that a trait bound, but like they have a common trait implementation which can be used as a trait bound. You want to throw them all into a single vec and loop through them to draw the screen. Sorry, zoned out. Um, okay. Um, they all implement a draw trait. You want to throw them all into a single vec and loop through them to draw the screen. You can't do vec impl draw because vec needs every item to be the exact same size in memory. But a button might be different, might be a different size than a slider. So I guess what they're saying here is that the issue is not that it's the issue is not about the trait. So it's not that, oh, you can throw in this type if it implements so and so trait. The issue is that they all have to have the same size. I actually didn't know that about vec. I knew that about array. So that's kind of interesting. Like I knew that. Yeah, actually, I don't think I knew that every single item has to have the exact same size. I guess that makes sense because, like, that's how they keep track of where to jump in memory, like when you're trying to index the various items. But then, okay, how would Dyn then help that situation? I guess let's explore that. Okay, so because a vec needs every item to be the exact same size in memory, and a button needs to be the exact same, and a button might be a different size than a slider. This is where Dyn saves the day. Okay, we have to put it behind a pointer because Dyn types are dynamically sized. Oh, I haven't covered, or well, revisited, I guess I should say. I haven't revisited the smart pointers section of Rust yet. I kind of touched smart pointers in the past when I was learning Rust, when I was newly learning Rust, but I haven't really used smart pointers nearly as much, at least not, directly. So I need to get into doing that as well. But okay, let's continue with this example. So the example that Gemini has given, I'm just going to drop it here. Okay. Wait, would it accept a trait? Wow. Wait, does it accept a trait here? Holy shit, dude, this is crazy. I need to talk to Gemini about this. Give me a second. Hey, I'm learning Rust. I had no idea that I could declare traits and structs um, even within main. Okay, all right. Um, okay, in Rust you can declare structs, traits, enums, functions, and even imports inside any block scope, including inside main. Dude, I actually had no idea about that. I didn't even know about the use statements thing. Like I knew about nested functions. I guess they're called local functions, or at least in C sharp they're called local functions. But yeah, I knew about nested functions. I did not know about the use statements, that we can actually put the use statements directly inside inside main. Actually, it says inside any block scope, including main. Here's a quick look at why this works, why it's useful, and a small catch to keep in mind. Okay, how it looks in action. You can encapsulate everything right inside main or any other function, and it'll behave exactly as you'd expect, but it remains completely invisible to the rest of your program. Oh, so it's within that scope. It's within that scope. Okay, that makes sense. That makes sense. Well, okay, hold up. Would it still be valid in, how do I test this out? Like, okay, we have draw, no, we have screen. Okay. Can I create some func O1 and have this accept a screen? I cannot. So that is why we need to, okay, all right. Now I get it. Um, though if it was a function in here, some func O1, um, a screen, that would work perfectly fine. Okay, all right, that makes sense. Um, but it remains completely invisible to the rest of your program. So we can declare a struct, we can declare a trait, we can implement a trait on a struct, and then all of that is valid, right? Like it's all only it's all only valid within the context of main. Other than that, it's not going to be allowed. Okay, why does Rust allow this? It all comes down to Rust's strict adherence to block scoping and its focus on item minimization, um, encapsulation, and cleanliness. If you only need a specific structure or helper trait for one specific function, defining it locally keeps the global or module level namespace clean. Okay, that makes sense. Then macro expansion. It's incredibly useful for macros. When a macro generates code, it often needs to create temporary structs or helper traits. By keeping them scoped inside a block, the macro avoids accidentally clashing with names you've used elsewhere in your file. Okay, all right. The catch, scope restrictions. The only major thing to watch out for is that these definitions are strictly local. If you define a struct inside main, you cannot pass it to a helper function defined outside of main, because that helper function has no idea that the type exists. Tip, if you find yourself wanting to write helper functions that use your local struct or trait, you can actually define those helper functions inside main as well. Okay. Hey, quick question. Are are wait, no, I think Gemini mentioned this. Okay, let me ask it anyways. Are nested functions called local functions? Yes, they are. In programming terminology, nested functions and local functions are two names for the exact same thing, a function defined inside the body of another function. All right, that's good enough for me. Great. Okay, so back to Dyn. Gemini gave this example of using Dyn. So this is a struct. It has a field called components, which is of type vec, and the vec's type is box_dyn. And it's kind of interesting because I have seen box being used a lot with Dyn. Um, I need to understand why this is because Gemini did give this helpful comment saying that because these types are dynamically sized, but I feel like I don't fully understand what that really means here. And part of the reason there might be because I haven't fully explored smart pointers, at least to the extent that I want to. I haven't really been able to explore it, so that might be why. By the way, I have like some ideas for I need to go back to my oh what is this? Oh wait, hold on, is that S? So S is for sessions. I just holy shit. Okay, dude. I did not know this. Usually what I would do is in order to join a different session, because I have multiple TMUX sessions, and you know what? I haven't touched Westterm's I haven't touched Westterm's words. Oh my god. I haven't touched Westterm's multiplexing capabilities yet, Westterm's multiplexing features yet. I don't know if I'm going to, if I'm being honest. Though I feel like, and I think Gemini would be the best to give me a comparison here, because I want to know, like, there's certain tmux features. I don't use tmux in a very advanced capacity, but I do use tmux heavily, like heavily. So this whole thing about, you know, tmux sessions, tmux windows, being able to attach to a tmux session, these things are really important to me because the session is hosted on one machine, but I usually access it from multiple other machines. So like that whole thing, the multiplexing capability, especially over SSH, that means something to me. So I need to make sure that those features, at the very least, they they work, and they are as seamless on the Western native side as they are on the tmux side. So I'm just gonna ask this question. Hey, I recently started using Western. I'm coming from the Kitty terminal. I heavily use tmux, specifically its features like sessions, windows, um, attaching over SSH, etc. Um, Basically, its multiplexing capabilities. Capa- Capability. Hold on, spelled capabilities wrong. There. Okay, multiplexing capabilities. I'm aware that Western also has muxing capabilities. It's, oh my god, let me just say abilities. Oh, I could just do capability. Yeah, okay. Somehow that might, like, never mind. Whatever. Also has, I'm aware that Western also has muxing capabilities, but I haven't explored them yet. Um, um, how well does it compare to Tmux? Is it on par or less than or more than? Okay, Western's multiplexing is incredibly powerful, but whether it's quote unquote better than Tmux depends entirely on how you use it. Instead of thinking of it strictly more or less than Tmux, it's more accurate to say Western does the same core things differently, and often more smoothly if you're willing to embrace its ecosystem. Here's how Western's native multiplexing stacks up against the classic tmux workflow according to your core use cases? Okay, local sessions and windows. In tmux, you split panes, create windows, and manage sessions using a prefix key like control B, which is what I do. It's rock solid, but everything is rendered inside a rigid text grid. In WebStorm, you get the exact same concepts. Workspaces equals sessions. Actually, yeah, that is true. Hold on, that is true. That is very true. Workspaces, because what I've noticed is that for any given single WebStorm instance, I think that's dependent on the process. I think so. um, for any given WebStorm instance, you can only have one workspace active, and each workspace doesn't, it's not limited to just one tmux, no, not tmux, one WebStorm GUI window. You can actually have multiple GUI windows that are part of the same workspace. And so anytime you switch to that workspace, whatever workspace you currently have active, its windows are going to get hidden, or its single window is going to get hidden. And that other workspace that actually has multiple windows, it's going to end up spawning multiple GUI windows for you. So, like, you actually have multiple windows um, that can be part of the same, multiple GUI windows, and then each of those windows can have multiple tabs, and then each of those tabs can have multiple panes. But yeah, you can have multiple GUI windows part of the same workspace. So it's essentially the same, if not slightly better in its own way than tmux. Okay, yeah. Tabs equals windows and panes equals panes. Great. Workspaces equals sessions. However, because WebStorm handles this at the terminal level, you get features tmux cannot simply you get features tmux simply cannot support, such as native graphics and fonts, images via icat, ligatures, undercurls. I have no idea what that means here. Oh, is that like the squiggly line? I don't think so. No, no, no. It probably means something else. Undercurls and complex emojis work work perfectly across um, work perfectly across splits. Tmux often struggles or requires complex overrides for advanced graphics. Yeah, yeah. I'm hoping that this issue that I have on the Yahtzee side, or with Yahtzee on the Tmux side, I'm hoping that also gets resolved once I start using the multiplexing support. I think a problem that I ran into, not really a problem, but it's just like I had to understand it before I started using it. I started trying to understand what is it called? WebStorm. I started trying to understand WebStorm on a much lower level to understand the various features and how they are implemented, and it just seemed like there were various concepts that I needed to get into just to get my own understanding of how things are working. Um, and that's kind of what made it take some time. Well, the other thing, honestly, is that I also got distracted with some other stuff, which is why I couldn't complete that research that I was doing. I'm going to continue that research. I'm definitely going to go back and continue that research. Give me a second. Hold on just a minute. Okay, so then true mouse support, resizing splits, clicking tab. I've actually noticed that resizing splits. I can do it with the mouse, which is definitely helpful because I haven't mapped the the functions for that. You can key map them, but they're not mapped by default. Um, and I haven't taken the time to map them. Then smooth key bindings. You don't need a clunky prefix key, though you can configure one. You can map Command D or Alt D directly to split a pane horizontally. Okay, then remote attaching over SSH. Apparently, this is a game changer, and actually, yeah, for me also, it would definitely be a game changer because I very heavily use that feature. Okay, this is where Westrum takes a radically different path than Kitty or Tmux. With Tmux, you SSH into a server and run tmux attach. If your connection blips, the connection stays alive on the server and you reattach later. The downside, you lose your local terminal features. Local clipboard integration can be finicky, and font rendering depends on the remote environment. Yes, I've noticed actually all of those things. Literally all of those things. Okay, Westrum has a TLS slash SSH multiplexer daemon. You install Westrum. You install Westrum on both your local machine and your remote server. You connect using Westrum's native backend. Westrum spawns a headless daemon on the server and connects your local GUI window to it. The result, if your internet drops, your remote session stays alive on the server. When you reconnect, your tabs and panes instantly restore. But because the rendering happens locally, scrolling is perfectly smooth. There's no lag. Your local shortcuts work flawlessly, and the clipboard integrates natively. Where Tmux still wins, and this is the catch, while Westrum is incredible, Tmux still holds the crown in a few specific scenarios. Ubiquity. Tmux is available on almost every server on Earth and takes seconds to install. Westrum requires installing a relatively heavy Rust binary on the remote server to use its advanced MUX features. Okay, that's fair. That's fair. I'm fortunately not in that situation where I have to, like, I mean, I'm in control of my entire environment. Let me just put it that way. I'm in control of my entire environment. I'm not SSHing into some other environment to get my work done. And literally both the remote and the local machine, local being the machine that I'm using as a terminal, remote being the machine that I'm using as a server, and they're both on the same network. Both the machines have Westterm installed. Okay, then the headless lifestyle. If you routinely connect to servers from a tablet, a phone, or different machines that don't run Westterm, Tmux is universal. Westterm's advanced session resurrection only works if you're connecting from a Westterm client to a Westterm daemon. Okay, that's fair. Then plugin ecosystem. If your Tmux setup relies on a dozen TPM plugins like Tmux Resurrect, Tmux Continuum, or heavy status bar themes, you will have to you'll have to rewrite those behaviors in Westerm's Lua configuration. You know what? Okay, okay, all right. You know what? Fine, fine. Let's step away from this for now and get back to the Dyn thing. Okay, how Dyn works under the hood. When you use Dyn draw, Rust creates a fat pointer. This pointer is twice the size of a normal pointer because it contains two things. One, a pointer to the actual data such as your button or slider struct, and two, a pointer to a vtable, a virtual method table. Sorry, zoned out. The vtable is just a list of the vtable is just a list of pointers to the actual implementations of the trait methods. When you call .draw, Rust looks at the vtable at runtime to figure out where to where the correct draw function lives and then jumps to it. Quick summary, when to use dyn. Okay, hold up. Hey, so I haven't really explored smart pointers yet. Is there any way you could teach me about dyn without getting into smart pointers? You can absolutely understand dyn without touching smart pointers like box. The reason people the reason people always talk about smart pointers with dyn is because of memory size, but we can completely bypass that using regular standard references. Let's look at how dyn works using just normal references. Okay, the core problem, how big is it? In Rust, the compiler needs to know exactly how much space a variable takes up on the stack at compile time. Imagine you have two different types that implement the same trait. Let's copy both of these. Um, okay, so these are our new, this is a new trait, and these are two, yeah, this is a new trait, and these are our two, well, sorry, this is a new trait, and then these are the two structs that I guess these structs are going to be implementing this trait. Okay, if you try to write a variable like this, let my hobby equals dyn my hobby, then Rust panics. Wait, not my hobby, just hobby. I didn't know we could do that. Well, I mean, okay, Gemini is saying that you can't do that. Um, give me a second. Okay, sorry about that. Um, if you try to write a variable like this, so let my underscore hobby, and then we specify a type. I didn't even know this was an option. Like specifying a trait bound for type annotation. I didn't know that was an option. Okay. Um, if you try to write the variable like so and so, then Rust panics at compile time. Why? Because it doesn't know if my hobby is going to be gaming, which is 4 bytes, or reading, which is 28 bytes. That's actually another thing that I've been doing research on because I don't fully understand how I'm meant to be calculating I mean, you don't need to go too deep into it, but I like to get sort of a mental model of a mental representation of what this is going to look like in memory. Just it helps my understanding, and it'll help me make more advanced, not advanced, informed, more informed decisions. um, this kind of stuff definitely helps. size, alignment, and the no drop thing. I guess that's later. This can't be dropped. Wait, this cannot be dropped. This needs drop. Oh, okay. I thought it was saying no drop because it's part of a struct and you don't want to drop a value that's inside a struct. So that's also why you don't move a value out of a struct. But then I guess with a struct, dropping will usually happen once it goes out of scope. Um, right? I think so. But then why is it saying here needs drop? I need to look into the drop thing as well because drop is a trait and it does get called, or its method does get called in certain scenarios. Um, yeah, so being able to see, okay, here it's not showing the size. To be fair, I guess the size is not really known. Here, the size is known. So if I created like a, I don't know, let's say num01, f64, I don't know if f32 is a thing. F32 is also a thing apparently. So if I do this, then I can see the size change, and this is the same as an integer, a 32-bit integer. Oh yeah, that makes sense, right? 32 bits. Yeah, I didn't think about that. It's 32 bits, so it's 4 bytes. It's 64 bits, so it's 8 bytes. Okay, okay. Um, right. So even if we specify something like this, it's throwing an error because the size for values of type dyn main hobby cannot be known. Okay, all right. So dyn hobby is called a dynamically sized type. You can't store it directly in a variable because its size is unknown. The solution: look at the pointer, not the data. How do we fix an unknown size? We hide it behind a reference. Whether a struct is 3 bytes, no, sorry, 4 bytes, 28 bytes, or 4 million bytes, a reference always has a fixed known size on your CPU. This is totally valid. This is totally valid Rust code that uses dyn without any smart pointers. Okay, so let's try this. Okay, so it's not complaining here. And in that case, I could probably create a gaming thing. Let's say 5. That's not valid. That is not valid. Is this valid? That's not valid either. So what's the complaint? Mismatch types. Oh, it's because I haven't implemented the trait for this. Let's try implementing the trait. Impl hobby for gaming. Okay, and then do that, and we are good. No, we are not good. Actually, now there's a different error, isn't there? Found struct gaming. Consider borrowing here. Okay, that works. That's crazy. So I'm guessing that's a temporary lifetime. Um, let's I don't know. Let's say gaming01 game01 equals ampersand gaming hours 2. Yeah, yeah, okay. Yeah, this is a temporary lifetime extension. Okay, so then that's how it's working here. So we hide this behind a reference just so that the compiler knows the size of the pointer, and it's able to bind the pointer to a variable, but that pointer is then pointing to something whose size is not necessarily known. But because the size is not, but because the thing is not bound to a variable, so I guess the compiler doesn't complain then. Am I understanding this right? Is that the reason? I mean, in my head, that's what I'm thinking the reason is. Um, I think so. I think so, yeah. So, the example that Gemini gave is here. I'm just gonna paste it real quick and rename this. Cannot find trade. Wait, did I define the trade? Oh, I defined the trade in here. You know what? Um, let's do it in here then, I guess. Yeah. So there's a function defined called show hobby, and it takes in a generic type, but like with a trait bound. Um, actually, would this still be called a trait bound? That's yeah. I need to. Though, hold up. Like, what if because this specific oh, okay, to be fair, Gemini is giving me this specific example because I didn't want to use smart pointers for the example. But I'm thinking like, wouldn't this also be satisfied? Wouldn't the trade bound without Dyn? Wouldn't the trade bound also be satisfied if we just did this? Required by a bound in main.showHobby. Okay. The trade main hobby is implemented for okay. And here we can just change this a little bit and say, um, yeah, is that okay? Yeah, that's okay. Yeah. So we can set up a trait bound, and in that way we should be able to pass. Technically, we should be able to pass both read and play. Oh, we haven't implemented the trait. We haven't implemented hobby for what is it? For reading. Okay, impl hobby for reading, and then this and that, and we're done. Okay. Just a second. Sorry, I'm just looking something up. Okay. All right. Okay. So what makes ampersand dine hobby special? The fat pointer, a normal reference to a struct is just a single address in memory, but a reference to a dine trait, like ampersand dine hobby, is a fat pointer. It is exactly two pointers wide. It carries a pointer to the data where the actual struct lives in memory, and two, a pointer to to a vtable, a tiny execution map generated by the compiler that says, hey, when they call dot practice, then run the gaming.practice function. Okay. When show hobby runs, it looks at the second pointer at the run. It looks at the second pointer at runtime to figure out which version of dot practice it needs to execute. That's it. No box, no heap allocations, no smart pointers required, just a regular old reference that happens to carry a little extra homework. Okay, okay. This was very helpful. For a second, I was wondering if um, if a simple input if a simple trait bound would have worked just fine for the function, but then I remembered you were only doing that for an example for me. Um, this um, what was my next like question gonna be? So this is super interesting. Am I understanding this right? Is the idea that because we are binding it to a variable, the size must be known at compile time, um, and because we are essentially using TLEs when doing so and so, when doing a statement like, so let me give an example here. Let my underscore hobby do that. Hobby equals ampersand gaming, um, gaming, oh, gaming hours underscore played 500 and that. Um, so we mainly need to make sure the compiler knows the size of the variable or value bound to the variable, um, but the size of whatever the variable is pointing to isn't much of an issue. Um, isn't much of an issue. Yeah, okay. So let's see what the response to that is. Okay, you nailed it. This is exactly right. You've hit on the fundamental rule of the Rust compiler. The variable itself must have a known size at compile time, so Rust knows how much space to carve out on the stack. Because a reference always has a fixed size, it's just a memory address, usually 8 bytes on a 64-bit system. The compiler is perfectly happy. It doesn't care if that pointer is pointing to a 4-byte struct. No, it doesn't care if that pointer is pointing to a 4-byte struct, a 4 gigabyte struct, or a dynamically sized Dyn hobby object. What about the TLE part? You mentioned TLEs when looking at so-and-so. If by TLE you mean temporary lifetime extension, you are absolutely spot on here too. Normally, writing so and so would be ampersand gaming, creates a temporary value that would instantly die at the end of the statement. Oh, actually, I didn't think about that. Wait, I didn't think about that. Hold on. Oh, wait, no, 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 it doesn't. I didn't think about that because temporary lifetime extensions make it so the object lasts until, or the temporary thing that has been created, it lasts to the end of the block. Okay, okay, I was on the right track. Creates a temporary value that would instantly die at the end of the statement, leaving you with the dangling pointer. But because you are immediately binding that reference to the my hobby variable, Rust smartly extends the lifetime of that temporary gaming struct so it lives as long as my hobby does. The coercion magic. What's really cool about that line of code is a hidden feature called unsize coercion. At compile time, Rust looks at ampersand gaming and says, okay, this is a normal pointer, so ampersand gaming, but then it sees you want to store it as an ampersand dyn hobby. Rust realizes game implements hobby, so it automatically upgrades that normal pointer into a fat pointer by attaching the gaming v table right next to it. Okay, all right. Okay, and to make sure I understand this, the reason we couldn't just do dyn hobby for the type annotation is because um, dyn, well, the dyn hobby object could have any type or any size depending on which object or which struct that implements it is passed in, but a reference would be a fixed size. Yes, you've got it 100% correct. That is the exact reason. If you write let my hobby dyn hobby, the compiler looks at dyn hobby and says this could be a gaming struct or a reading struct. I don't know how much stack space to reserve for this variable, so I'm going to throw a compiler error. But when you change it to a reference to dyn hobby, the compiler says, okay, this is a reference. I know exactly how big a reference is, 16 bytes on a 64-bit machine, because it's a fat pointer. I can easily reserve that space on the stack. To visually cement this, here is exactly what your stack memory looks like when you use ampersand dyn hobby. The concrete, wait, hey, the diagram you tried to show me didn't render. Oh, this is great, dude. Hold on. Gemini gave me an ASCII diagram. So let's print that out here. This is what it looks like. So this is the stack, and then this is the text and data segment. So this is, well, I want to say heap, but it's not necessarily on the heap. It's a different section of memory though. It's not the heap necessarily. I need to look into like where exactly these segments reside. I know that they're part of the the memory itself. In fact, like the data segment would be part of the binary. Or, well, the data segment is a part that's carved out um, to hold certain types of data. I'm trying to remember if the data segment is also part of the binary, because you do have like read only memory sections. So like even read only memory stuff gets um it gets its own separate section, and that stuff is definitely part of the binary. I'm gonna have to look into this. I'm not gonna try and guess what it is. Anyways, so we have my hobby so and so. This is our object, and this object is a pointer. It's a fat pointer, so it has a data pointer and a vtable pointer. So it's one pointer containing these two things, and what it points to is one, the gaming struct, and two, the gaming vtable, which contains the functions that are implemented on gaming. So this is the oh data text is our body, and data is the variables that are usually allocated. I'm only taking these guesses because I've done this stuff in assembly, where you have the text section, which is essentially your body of instructions, all the instructions for the program, and the data section usually holds variables that you wanna have created within the program at that time. Um, yeah, yeah. So I guess that's why we are doing text and data segments here. Okay, all right. Now, what is Gemini saying in terms of the explanation? Okay, breaking down this ASCII map on the stack, um, because you used reference to Dyn Hobby, Rust allocates exactly two words of memory, 16 bytes total on a 64-bit system. The data pointer points directly to wherever the data pointer points exactly to wherever the gaming struct is living in memory. Sorry, zoned out. Okay, sorry. I'm just looking at something, so zoned out again. Okay, the data pointer. This points directly to wherever the gaming struct is living in memory. Then we have the vtable pointer. This points to a tiny read-only table the compiler generated specifically for the gaming struct's implementation of Hobby. When you call myhobby.practice, Rust looks at this table, finds the memory address of the actual function code, and executes it. If you had used reading instead of gaming, the stack variable myHobby would still be the exact same size. Okay, because it's pointing to, yeah, because it's a pointer. All right. And I guess in this case, it's a fat pointer because we have the memory address of the struct and also the memory address of the v table for that struct. That's why. Okay. Okay. All right. Okay, you know what? I feel like I get where we would be using Dyn now. Um, okay. Are there any other such situations where I would be using Dyn? Now that you have the memory layout down, identifying when you need Dyn becomes a lot easier. There are two main scenarios where standard generics slash infiltrate completely fail, forcing you to use Dyn. Um, heterogeneous, heterogeneous heterogeneous collections, or heterogeneous. Let's say heterogeneous collections. Mixing types in an array slash vec. This is the most common reason to use Dyn. In Rust, every element in a vec must have the exact same type and size. Okay, if you try to use a standard trait bound, wait, can I get away with storing a bunch of pointers on there? Would that work? Let's get rid of, yeah, we can use this as an example. That's fine. We can actually wait, get rid of this. Let's hold on to that. Get rid of that. Get rid of that. Reformat. Done. Okay. Now we have these. Okay. Let's say some vec o1 equals vec. Um, actually, I need to specify it like this: vec ampersand play ampersand read ampersand play and ampersand read. Okay, some vec o1. Sorry, zoned out. Okay, now semicolon expected. Okay, and it should be saying that it expects type annotation, mismatch types. Okay, all right, that's fine. What we can do here is say the type should be vec dyn hobby. Would this work at all? Holy shit, this works. That's crazy. Wait, that's crazy. This works. This works because I'm storing references. This works because I'm storing references to these objects that implement this trait. Holy shit, dude. I learned something new. We learned something new. That's crazy. So now now I'll know in I'll know words. Oh my God. Now I'll know which situations I should be using uh which situations I should be using dyn in. So one is this heterogeneous collections. In Rust, every element in a vec must be the exact same type and size. If you try to use a standard trait bound to create a list of different hobbies, the compiler will reject it. Okay. Uh, because because gaming and reading are entirely different types with different memory footprints, Rust can't put them side by side in a standard vec. The dyn fix, by using references to dyn hobby, every item in the vec becomes a fat pointer of identical size, even though they point to completely different structures underneath. Okay, so that's the first scenario. The second scenario is conditional return types. Conditional return types from functions. Imagine writing a function that returns a hobby based on user input or a random choice. If you try to use impl hobby as the return type, Rust expects the function to return one single concrete type from every single execution path. Okay, the compiler can't allocate space on the stack for the return value of pick hobby. Pick hobby is this function that Gemini gave as an example. So it's also saying this is not gonna compile. Um, yeah. It is mentioning that this is not gonna compile. I'm guessing yeah, would that work here? Actually, I like that it's giving this option. Um, it's saying dyn, but like, oh, I guess that's just its own what it determined. Okay, so then there's that. And actually, this would still not work because we need a lifetime specifier because the, yeah, this would not work. Actually, this would not work. I feel like here I would need to, here I guess I would need to wrap this into a box. What is Gemini's recommended fix for this? Yeah. Gemini is also wrapping it into a box. Because then with the box you have accurate memory. Okay. Right. The dyn fix. To make this compile, you have to return a pointer. Note, since you can't return a reference to a local variable created inside a function, that's why the ampersand dyn thing didn't work, because that works if TLE is in effect. The temporary lifetime extension is in effect. But then we are literally sending this out. So any reference that gets created is going to die instantly. And so we can't return just a reference. We would have to return the concrete type, but because dyn hobby cannot guarantee that it's going to be a fixed size. That's why we run into this issue. Let's just reproduce that. Rust type cannot be a trait object without pointer in direction. Doesn't have there you go. Doesn't have a size known at compile time. Consider returning an impl trait instead of. What was the issue with impl trait? Expected gaming. Okay, okay. Um, Sorry, I was just distracted with something. Okay, you know what? I think I think that's going to be it for today's stream. I'm going to continue reading this, and I'm really going to try and finish reading all of this, all of this extra stuff that I have opened up. I'm going to try finishing reading all of this, and I need to get back to working on KB Tool, make some progress with that, and stop getting so distracted with like a bunch of these different, little things that I'm learning extra. Um, I mean, it's helpful, definitely. Like today, we learned about Dyn, and now I know in what situations I would be using Dyn. And once I learn about or revisit the concept of smart pointers, and well, to be fair, what I know about smart pointers now is as good as saying that I don't know anything about smart pointers. So yeah, I mean, I might as well just say once I learn about smart pointers properly, I guess then I'll be able to use Dyn even better. Okay, all right. So that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.